Welcome to video 2 in the acid, bases and salts series. This one we're just asking the question, what is a base? Right, in the previous video we looked at what is an acid. An acid is a proton donor. Okay, so we'd imagine a base to be something opposite of this, and indeed a base is a proton acceptor. Okay, all right, now what accepts protons? All right, let me show you things that accept protons. A base accept protons, they accept protons to make water. Okay, and what things will accept protons to make water? Well, an OH minus ion will accept a proton to make water, and an O2 minus ion will accept 2 protons to make water. So anything with these ions in, these two here, are classed as bases. Okay. Now to have the ions here, these are both ions, aren't they? They must be ionically bonded things. Okay, so to have ions, they must be ionically bonded, and that means they must be metallic. Metallic hydroxides and metallic oxides. Now these things are known as bases. Okay, they're bases. Metallic oxides or metallic hydroxides are the bases. Now we can't get non-metallic hydroxides or non-metallic oxides because they wouldn't be ionically bonded then, they'd be covalently bonded, and in fact they're acidic. So bases are metallic oxides or metallic hydroxides. Okay, let's have a look at an example over here then. Let's have a nice a reaction that we all know and love. Hydrochloric acid plus sodium hydroxide gives us sodium chloride plus water. Okay, now what's what in this? Well, this thing donates my H plus, so this thing is the acid of the two, and this thing gives an OH. Now the OH will accept the H from the acid, so this must be our base. Okay, so these two things come together and they're going to form the water. The things that are left behind, by the way, we have the chloride ion from the acid and the sodium ion from the base. They're just going to be left behind and they're going to form what we call the salts. Okay, and water. All right, so if anything accepts a proton, it is a base. And on our course, on our syllabus, it's hydroxides and oxide ions. Okay, so let's have a look at another one. Another acid, H2SO4. Let's do copper oxide. Okay, what are we going to get? Well, the acid can be split up into 2 protons because of their 2 H's plus a sulfate ion. The copper oxide is a copper ion. That's not the base, that's just the carrier ion. And the oxide ion. Now the oxide ion is the base. Okay, what are we going to get? Well, the oxide ion here, this guy, will accept these 2 protons. Okay, so these guys will come together and that will give us water. What's left? Copper ions and sulfate ions, and that's going to give us copper sulfate. Okay, so let's do the proper equation there. The water comes from the protons and the basic oxide ion here to give us water, and the salt comes from what's left, basically. All right, so overall, we could say what's going on. Well, the copper ions and the sulfate ions aren't really joining together, but we have 2 protons from the sulfuric acid. It's going to react, whoopsie daisy, shouldn't do that. It's going to react with an oxide ion to give us water. Okay, what's going to happen is this, by the way. This is going to happen in 2 steps, isn't it? One H plus is going to react with the oxide ion, and that's going to give us an OH minus ion, and then this OH minus ion is going to react with the other hydrogen ion to give us water. Okay, so as you can see, this reaction H plus plus OH minus gives water is the same as this one, H plus plus OH minus. Okay, so very basically, an acid is a proton donor and a base is a proton acceptor. What things accept protons? Metal hydroxides, because they have an OH minus ion, they can accept a proton. And metal oxides, they have an O2 minus ion that can accept 2 protons. Okay, and here we have this equation down here. This is known as the ionic equation for neutralization. Okay, and if you add any acid to any base, you'll always end up with this equation. If you get rid of all the spectator ions, you'll end up with that equation. Okay, thanks very much.